When can we say that a binary operation is commutative? That is the task for this video. But first, let's remind ourselves that the consideration here is that the operation is already a binary operation. Hence, we follow the idea that the operation on a certain set S, let's say set S, is already closed. Okay? That would mean if we pick elements A and B in S, and we have here the binary operation star, if we have A star B, it's still an element of S. Okay? That's the idea for the binary operation. Now, when can we say that a binary operation is commutative? Here is its formal definition. A binary operation, okay, let's say star as indicated here earlier, on a certain set, let's say set S, is commutative if and only if, so this is the condition, if and only if A star B will have the same result as B star A for all A and B element of S. Okay? That would mean, regardless of which element is written first or considered first in our star operation, the result is still the same. And then again, the result is still an element. Both of these are also element of S. Okay, so this is when can we say that a binary operation is commutative. Yes, not necessarily all binary operations are commutative. It depends on how it is defined, and definitely it depends on the certain set. Because as we can say that the binary operation is related to a certain set before we can say it as a binary operation. One example here is, of course, the addition on the set of integers and even on a set of real numbers. If we're going to add any two elements from a set of integers, okay, definitely they are also element. The result is also an element of integers. It's also true if we're going to add two real numbers, the result is still a real number. And for this case, the addition is a binary operation, specifically is a commutative binary operation on Z and R respectively, because aside from the result being elements of the said sets, we can also get the same result. Let's say A is equal to 1 and B is equal to 2. So we have A plus B is equal to 1 plus 2, which is a 3, right? Element of S, being this is element, sorry, let's not use S. Let's use here real number or integer, okay? And if we're going to have B plus A, if we're going to interchange them, 2, sorry, that's 2 plus 1, sorry, which will still get 3. We have the same result and still an element of real number. We can see that the addition is actually a commutative binary operation on the set R, real numbers, and it's also even true on set Z. As mentioned, not all elements, or not all operations in a certain set may be considered as commutative binary operation. It depends on how the operation and the same set be stated or defined. So this is how we identify a commutative binary operation. Thank you very much for watching.